My name's James, and last Friday I got permission from my bosses to open source, finally, a bit of code I've been working on and off for about 10 years, about a week a year for 10 years, admittedly, which is usually when I'm in this room and the Plugfest downstairs. So just to give you an introduction, I'm principal architect of software at Grass Valley, which is a company that makes video solutions for lots of things. So if you ever watch Formula 1 or ESPN or lots of different sports channels, news channels, they use our equipment to make TV. And it's also used to make film finishing. I code pretty much every day, so whilst I'm also an arm waver, I don't have any reports, I'm not a manager or anything, I like coding, and I've been coding for nearly 40 years. I started when I was 9 years old in 1979. And I haven't been at Grass Valley for nearly 20 years. I've been in my job for about 20 years, but it's been merged and acquired and M&A'd, and so now I work for Grass Valley, a Belgian brand, which is quite fun. My research interests, because I've got a PhD, the research interests at work are to do with file system innovation and modern video production. By modern, I mean using the web to build video production systems. My PhD, I won't bore you about what I did, but what's quite nice is I've now got a visiting research fellowship at Brunel University, which usually means I've got access to their beer budget, so that's quite good fun. So over the years, I've talked, I think this is my 6th presentation at SDC, and obviously the slides are online, you don't need to read all this, but you can, if you wanted to be very bored, you could go and look. I did quite enjoy last year's talk, some of you might have seen that, where I embedded Python in our SMB server, and we had little strings of Python being run as folder names. It's a bit odd, sorry about that. But what we're going to do this year. So I'm going to give you an introduction and a rationale, because it's quite an odd thing to have done what we're doing. And I don't mean competition in the sense that we're trying to compete with anything, but how do you write a file system on Windows? That's the competition we're trying to look at. And then I'm going to give you a code tour, and it will get nice and techy. So we're going to have lots of traces of SMB floating around and bits of code and lots of demos, live demos, not recorded videos. Then I'm going to talk about, in the open source code, what works, where there's areas for research, and there's lots, and then there's numbers of debts and ideas for projects. So, hopefully in an hour's time, or less than, you'll be having a beer, and you'll realize how elegantly simple SMB is, and how easy it is to just look at and say, yeah, we can code that. And then you'll also find out how hard it is to code an SMB server. It's both at the same time. It's really elegantly simple, and it's rock hard. And this code base, which you can now play with, solves some of those hard problems. Obviously, there's lots of other ways to solve those problems. But I've maybe taken a different tack in how to solve some of the hard problems. And the thing is, I've very much based this code in user mode on top of Windows. So it uses the Windows APIs to do the hard bits. So we can also, by the end of it, hopefully, give you some ideas about what you can do with the code. And it isn't necessarily a normal file system. In fact, it's not a file system at all. It's a protocol implementation. So we're going to talk about what it's like to write an SMB2 server that runs on Windows. And this really does have some interesting benefits, having your code sat on user mode on Windows. And in user mode, you can do loads more than having to be in kernel mode. And so I really like this whole approach of user mode, C++, all that sort of stuff. And now it's open source. You can have a play too. So why would you code SMB on Windows? There's a world-class implementation of SMB on Windows. Thank you very much. And it turns out that I've got data in the Windows ecosystem I'd like to offer as if they were files. And using the IFS kit and its ilk is really hard. Well, you get to blue screen a lot. In developing the SMB server, when I did CIFS SMB1, I could blue screen the Windows client. But I have never blue screened Windows. OK, I'm about to do so, I'm sure, just having said that. But I've never blue screened Windows because I've coded an SMB server on Windows. So it feels like I've got a nice safety net. I don't have to use the IFS kit. But the other benefit of this, if you go and look at the Fuse model and things like that, that's offering a DAS, a direct attached storage, whereas this is a NAS protocol. So suddenly you're in this world of being able to play with your network connection and what you can do with networking. So I just literally copied off Wikipedia. Just in the Fuse Wikipedia article, lots of different ideas of file systems in user mode. And that's a really good idea, and Fuse is really good. But on Windows, it's really hard to get to something like Fuse. And there's some really good offerings, 2 open source, 1 commercial, that use the Fuse style model in the Windows ecosystem. But again, it's hard. If you've got a different update to Windows, some of the data structures in kernel mode and the IFS kit can change size. Historically, they've done so. So you've got to keep tracking the state of the actual data structures in kernel mode. Whereas if we code against SMB, it's a defined protocol that is immutable. It may have semantic changes. In retrospect, we just learned in the last hour, but that really is rare. If you're sitting on a particular version of SMB, then it isn't going to change underneath you. So therefore, the clients are going to honor that protocol. It's an agreement. And all of these are, like I said, local file systems. So the code base, getting into it, the URL is in the slide deck. I put it on GitHub. There's basically about 80,000 lines of C++. And there's about 14 projects in it. There's 1 or 2 other little exes that build. And it builds a load of DLLs and 1 exe. The main exe is called kernel server. It does nothing except it can load other DLLs. The code base I took this from is about 4.5 million lines of C++ and does lots of special effects and things like that. And I just got permission to open source this little part of it, the SMB bit, and the little bits that I need to boot the SMB server. So it is written in C++, but it's pre-modern because we started this a while ago. So we've got our own smart pointers, and they're all, it's got its own threading abstractions, things like that. But it only depends on the Windows SDK and Boost. So if you've got Windows and a Visual Studio, which you can get for free off Microsoft, and you can get Boost for free, then basically you're in a world where you can build 64-bit Windows off this code, and you're good to go. So there's 2 sort of sets of projects. If you notice, there's numbers of kernel, things that start with the name kernel, and they have nothing to do with SMB at all, but they're nice little helper things. So there's a thing called the debug driver, which basically walks a stack if you ever crash. So you get a nice log. And the other 2 things that are useful, there's a console log driver and a file log driver. So it logs nice HTML to a disk for you to see when things go wrong. And so when you do logging, you can see, and we'll see it later, it logs into a little folder that's hard-coded, but you can change it in the registry. So the real meat of what we've got, these DLLs, all start with this word QCIFS. So you can tell it's slightly old, because the company I first worked for was called Quantel, and obviously we're implementing CIFS. So this is now Grass Valley, and we're implementing SMB2 and 3. So, but I didn't bother changing the names. And the first DLL we're going to talk about in depth is called QCIFSTest, which really is a noddy implementation. But before we get there, I'm going to show you a little bit about the ecosystem we've built. So there's a README at the root of the GitHub repo. Basically, it says get Visual Studio, get Boost, configure a couple of pars, and hit release. No, hit build release. That's all you need to do. So it's really simple. It's just a network server, just using WinSock, and it binds to port 445. And as long as you obey the protocol spec, then it's all just going to work. It's that easy. In fact, we can actually do that. So I'm going to run up my little SMB server. And I don't know if you can see that, but I should be able to do that. Zoom in a bit. We can't bind to port 445 because it's Windows, and Windows is doing SMB, thank you very much. So the first thing to overcome is the fact there's an SMB server built into Windows that's hogged 445. So what we're going to do about that? So we could kill the server service, net stop server, and that's quite draconian. It turns off a lot of Windows doing that. But there's a more subtle way, which is actually to keep the server service running, but just snip its connection to port 445 so that it frees up the port, keeps the server service running, and then you can sit on it instead. And doing that has got loads of benefits, which we'll come back to later. So there's a part of the project has got a thing called Free 445. Yes, absolutely. So yeah, there's a branding in here. I didn't realise. That'd be marvellous, wouldn't it? Free 445. Yes. And so the theme from Matthew's talk earlier, where he's using Quick instead of TCP, you've got the huge options to go to different ports. And that's there's a whole world-changing sort of thing going on, isn't there? Right. So if I go over here, then. So I've just done a net stat, accept, and I've got port 445 in use. So then I'm going to go in here. Delete. So Free 445 is part of the open source stuff. Builds to a little exe. Oops. So, if you go and look at this, what it's done is it's used an API which enumerates the TCP transport, the transports available in Windows, and we aren't allowed to delete the NetBIOS SMB transport because we're not in local admin elevation, if you understand me. So now, hooray, we've just deleted the connection between the server service and port 445. So if I go back now to my netstat -an, it went too far. Here we are.
Have you ever done that with PowerShell? I think that's a PowerShell.
Oh, I don't know PowerShell. I know Windows quite well, but yeah. Anyway, we have now freed 445. We can, yeah, absolutely. Hurrah. So if I rerun this little beastie, oops, then we get less red now, which is nice. And it's bound to 445. Hurrah. So job done. Let's go back to this. So having to do an elevated privilege running 445 every time you boot your server isn't particularly good. So what I've actually written is a little service that the main piece of software installs. You need to be elevated to install the service, but every time then you boot, it can run this service and without being elevated, cause 445 to get disconnected. And it stays disconnected until you next reboot Windows, when it will boot with a nice configuration with 445 connected to again. So we're now in a world where this service can basically allow us to get at and remove the server service or 445 without being elevated. Question?
So a couple of slides ago, so it's preferable to just disabling the server. Why would that be?
So the server service offers lots of facilities, which we're going to rest on them later in the implementation. So it's quite useful to have it hanging around. So, hooray, we're bound on 445. So the next thing to do is a net use command. And it's easy, isn't it? You just do net use, there's a couple of SMB packets to process, and then you're good, you've made a connection. And I'm just going to talk through, a few traces are collected earlier of this code. So basically, we've just got one little project called QCIFS processor, and in there is all the handling of SMB requests and replies. And there's a bit of session work in there too. So we've got a lower level thing called a socket server, which does an I/O completion port. And it uses transmit packets as another Windows API. So basically, there's no mem copies anywhere. Things come in off the wire. Transmit packets allows us to do scatter-gather collections from user mode and puff them down to the NIC. So you don't need to do mem copies. You can just assemble things in RAM and pass them down. The SMB2 request basically wraps the payload that comes off the wire and does the right thing to parse it and build data structures, which are C++ structures. And then we can build responses that then basically build these transmit packets to send things back again. And dispatch command, basically, there's only 19 SMB commands, so it just dispatches to different functions. So the first thing we do is we need to negotiate a protocol. And for this example, I'm choosing the simplest, 2.02. That's terrible, isn't it? But it still works, and Microsoft still honor it, and so do all the other major clients. So you can stick on 2.02, and you've got a minimal set of SMB2 you can play with. And that's all we're trying to do. We're trying to shim in so that we can play file systems without having to do heavy lifting. So then there's a little bit more to do. We do need to deal with the session chatter. It's going to connect over to a session and do a bit of logging in and authentication. And this process generates the session key for the connection that you've just made. And that's important. But it's much easier in user mode on Windows because there's all these lovely APIs we can call. So there's the SSPI API. That basically allows us to basically take the packets that come in on the wire on the SMB and pass them directly as payloads into these handlers, and they do the right thing and then return the right payloads, and then you put them back in the right place in the SMB reply, and yippee, you've done all the session GSS API stuff. So we haven't had to do much heavy lifting. The other thing is the bcrypt API, part of the Windows API again, can do all the encryption and hashing and things that are required for later on when we come to signing. So we've got in the protocol doc this marvelous function. I don't really know what that stands for, but it's NTLM v2 authentication, and you have to put in your password, user, and domain, and then it'll hash it. And there's a nice worked example in the PDFs that Microsoft supply about exactly how to lay this out. And this is exactly the code that's basically in the open source that basically does that. It's just a straight copy and paste from the PDF docs and then coded using the bcrypt APIs. It's easy. Well, easier than having to do it all yourself. Okay, if you get a bit wrong, then it just says no. Computer says no for about 2 weeks, then it suddenly works, then you don't touch the code ever again. So, when did the validate negotiate info come in? For years I never did signing because I didn't need to. I just wanted the minimal set of SMB to get a file system working. And then this marvelous validate negotiate info came along, which is basically after session setup, you've now got signing enabled, so then you come in with this packet that is signed, whatever you've said on your server. The client demands that you sign the reply to validate that it's negotiated the right thing. So you have to support signing to support SMB2 server on any of the clients nowadays. Okay, so we've now got through NetUse and we've now managed to get a connection. So here we are, let's just have a go. Yippee! So we've just done all that. And as a little aside, a bon bouche, if you like, who can tell me what this is? Nothing to do with SMB. Any guesses?
It's one of those old...
A Bainbridge? A Babbage machine?
It is. It's a I didn't build it. It's built by a guy in Western Australia who's obviously got far too much time on his hands. But it is pure Lego. There's no glue. The only non-Lego in it are the numbers printed in paper. And he's got videos of it working.
Awesome.
And it's got the same tolerance as Babbage would have been able to build with brass. Wow. It's just sublime, isn't it? So I thought I'd put, a little bon bouche to keep, mid.
It needs a statue of Davis.
It certainly does, that's it.
Sydney's it right here.
But let's get a Lego SMB server, that'd be huge.
Challenge me.
Can you imagine all the Legos in the Plugfest? Yeah, okay. So then this test share, QCIFSTest, I've just coded in it some simple files that can load up, and I've just got some media in here, that just MXF files that play, and it's just, oh, we've got music. I didn't realise that. Anyway, so it's just basically some content in there that's hard-coded in the code, but when you actually come to the code,
sorry, you hard-coded a video into your servers?
Well, no, I hard-coded some example files.
Oh, I get it.
So basically that thing we've just connected to, the test, is a RAM-only weird thing that just answers some questions like what's in your folder structure. And I just coded, for example, so a couple of 4 files that are on my C drive and mapped them into this test virtual file system just to show you we've got some content.
But you're showing us that you've cheated, so we've got it.
So this, everything on this demo is checked into the, apart from these actual files, but all the code I'm running is live on the GitHub repo, so you can play. But the point is, I've made an indirection. I'm a computer scientist, and the ultimate power we have is an indirection. All I wanted was to have an indirection between all of the ecosystem that is Windows and the SMB server, so I can get in. I just want a way in to offer my file systems. And this seemed to be, hasn't been the easiest, but it's been the most fun I can imagine anyway. So anyway, that's a bit of code. So this, what it can do, there's some simple bits of code in here. Add virtual file, basically, there's a number of layers between the SMB server and these plugins. And there's basically a framework. I'm jumping around a bit. I'll come here. So I'm talking about this QCIFSTest. The actual test code is about 600 lines of code. And that's mainly plugging into the framework I've built that supports quite a lot of heavy lifting to do with coping with SMB, change notifies and file directory creates and all the other stuff that goes with making an SMB server. But having that little amount of code that can basically support creating files and folders and doing all the normal semantics of a file system, it doesn't persist. So if I stop running it, it's all in RAM, it all gets thrown away. But that's just the simplest little demo I could think of. So that's QCIFSTest. So in the actual code, there's a singleton, which is called an iQCIFS processor. And you can get at that to attach a resource. And a resource is basically a share. And then that will then connect to the socket server and start getting, it will say, oh, is there a share? It gets a connection. Great, it's called test. It starts chatting to it. And then it asks for a tree resource, factory, so that can then make a tree resource. And basically, we've got a very easy way into getting into file systems research, which is really what I want to play with. So there's a few slides on code, but basically, the little test loader inherits from a few different interfaces. I create, I rename, C child loader. The ref count thing is our own smart pointer thing, because it's before it's modern C++. But basically, you can use these mix-ins in the code base to decide what you want to support in terms of your little implementations of folders and files. And there's a number of few mix-ins you can pull in. The main thing, though, is there's a visitor pattern. And I child load a visitor. And you can call update file and update folder on those. There's numbers of overloads that take different forms of files and folders to be basically supported. And there's two little file-based interfaces, an iRead callback and an iWrite callback. You can make immutable read-only files, or if you make mutable files, like a Word document or something, then you can make an iWrite callback, which inherits from iRead callback. And this update folder, you can see it takes lots of these different interfaces, but the only one it actually needs is a name and the child loader. All the rest, you can just put in nulls if you don't want to support that part of the interface. But if you do, then you just put in these extra mix-in implementations, and then suddenly you've got notifies and deletes and renames, all that sort of support. Depends what sort of type of file system you're trying to write. In terms of files, again, we've got this sort of mix-in thing. A file event is basically all to do with notifies and deletes, and you can have a read or a write callback. And even a writable file can be read-only in terms of non-deletable, even though it's, you can write to it. So it's very simple, the iRead callback. What can you do on a read-only file? Well, you can find out how big it is, and then you can read the bytes within it. And then there's a few flags. So you can set a can execute flag, which controls some of the ACLs about whether you can run, so you can actually store a DLL and determine if it can be runnable or not. And you can basically control caching to do with SMB batch hop block or not, just with a Boolean. So it's really quite blunt, but it's enough to get quite a lot built. And because this is a framework, it's easy to go inside the framework and actually get much more rich in your implementation of op lock ranges, lock ranges and things like that. So the write callback just basically has 2 extra functions in it, which to be able to set the size and write things. Cool. All right, so it's a little bit more code. The basic file, which we just saw the demo of, we just opened these, the Lego. That was a basic file. It just has a read callback. It's read-only. There's another implementation in the test thing, which is just implements a write callback, and you can see how that works in the code. Cool. Right. So it's all very interesting having a noddy file system, but let's go and look at a different thing. So here. So I've made a thing here called QCIFSTest. Why would I call it SOFA? So there's an open source database called CouchDB. Anyone use Couch? So Couch, obviously, another name for Couch is SOFA. So here I've got an empty database and there's nothing in it, but my SOFA file system is resting against this particular it's hard-coded to look at the music database in my Couch database. So now what I'm going to do, QCIFS, oops, you just can't get the demo staff, can you? It's got Python in the demo again, but this is differently than last year. So my little Python script, in fact I could load it, is basically, it's looking at my D drive, which has got some music in it, and it's using a plugin you can get off the web for Python called ID3, which can read some of the metadata from an MP3 file. And so I've chosen to read out durations and track numbers from some albums I've got on my CD drive. So now if I go back to my Couch database, I've now got 136 records in here. I haven't put the actual MP3 files in it, I've just put metadata in it. So if I go back to my file system, so I've got some Bowie and some Zeppelin. That's nice. Oh, I've commented out that thing. Let's just do that again. Need to have Motorhead, I'm sorry. I don't need it for the demo, it's just a principle. Anyway. Oops. So I coded this literally on the flight over here, and there was a couple of good films on, and I had some gin and tonic. So I had a 12-hour flight, but it was compressed to about 5 or 6 hours of coding. It doesn't take long to build something quite fun. So in here then, I've got my Motorhead album. Oh, it was after the gin and tonic I coded, very much. So then I've got my album, 20 MP3s. Now what's happened, I've done a query against a view in CouchDB, and that's come back with paths, which I've then used the CBasic file to mount each of these as a source file. So the actual bytes are stored on my C drive, but I've put an indirection in. So if I go and look at other folders in here, I've got this thing called track nums. So these are all of the files, basically with the number of the track on the CD as the first couple of digits in the actual file name. So I've just added metadata to the content. So then what you can do, quite easily, is you go in, I'm going to edit the file name here, and I'm going to go key equals, someone shout out a number between 1 and 10. 7. Just is doing a little query against things, lots of logging going on, thank you. So now, in this folder is only the MP3 files that are on track number 7 in any of the CDs. Why would you do that?
Why would you do that?
Utterly ridiculous thing to do. But it just shows that you can put a database in a file system, because it's in user mode. So then I'm going to go to durations. here I've added all the different durations as a first attribute here. And if I'm in a sort of, well, yeah, sorry, you can see the effects. But, so durations here, I'm going to put in another thing here, which I can say, end key. So think of a number between 100 and 300. 200. So if I'm in a mood for short songs, then all of these are 200 seconds or less. It's just basic database queries. So the folder structure, the folder content is purely driven by views in CouchDB, and I'm just passing the strings through, and then the replies populate the folder. And all of this is a very odd thing to do, but we've found that having RESTful file systems, having path names with semantics, is interesting and useful. It's not a file system, it's a protocol implementation of an SMB that allows you to do things with files. You see the distinction? So there's no C drive behind here, there's no NTFS. It doesn't assume anything behind it. You can do what you want. So that felt like a fun thing to...
Did you send back a change notify to the client when you...
I could have done if I'd had a longer flight or less gin. So, but basically, yeah, change notify works, and Couch does have a change notify you can put on it's got a long pole, and so I could have hooked that in. Maybe I'll do that tomorrow in the Plugfest. Yes, so change notify works. Yeah. Cool. Right, so where have we got to? We've got to test, fine, sofa, lots of fun, but it just shows, hopefully, some of the power of having your own SMB implementation, not an IFS. We could do it with IFS kit, but it's just going to be hard. You know, playing with something like a Couch thing, or playing with an object store, or playing with anything that's modern in HTTP and layer 7. It's going to be interesting from kernel mode. Or the other thing I can do is just stop it. It's just a piece of C++ running as a user mode program. And because Matthew and his team's code is so nice, when I run up the server and reconnect Sofa, re-click on Sofa or test, it just reconnects again. And doing that with kernel mode, you need to reboot the server and start again and load the driver again. And you know, it's just more pleasant to be in user mode. So it is a NAS. So it's so much more than a loopback server. The last line's the most important thing. There are no warranties on this code at all. In fact, the license is put out is Apache 2. So you can do what you want. But there really is, it's working from what I've done. Oh, there's a question from Jeremy.
Are you going to take pull requests?
I would love to. I don't know how they work. But no, I really don't know. I mean, I'm just learning Git and GitHub, and that isn't the world I've come from. But I'd really like to invite the community to play. That's very much the point. So I'm sort of telling people about it. But it has been tested in the Plugfest, not very successfully, but it does work a little bit with OS X and Linux and Solaris and Windows. I'll talk about OS X next. Oh, hello, question.
Just one thing. If you do accept pull requests and the significant contributions, make sure you get their
Copyright and acknowledgement, and a license.
Their ability to submit under your license.
Oh, okay.
So otherwise, you should get anonymous pictures of the code. You don't put anything. We have a whole sign-on mechanism that allows, if we get a picture of the code from someone, we say, that's great, but before we converge it, please sign this email. Send us a signed email that says, and
Okay, all right.
you have the right to give it to us under the license that you're claiming you do.
Yes.
Otherwise, I don't want to get you guys into trouble if you've heard.
No, I'd love to learn from the community about how to do this, because I don't want to get into trouble. Because I work for a company that own the copyright on. Yes, exactly that. Okay. So what I showed you is running 202, but there's a hash defined in the code to say turn on 3. So we've got some SMB3 beginnings of the implementation of SMB3. And I've done some research, as you know, in some of the other talks I've given, about how to do scale out and fail over. And there's some really interesting parts of the SMB3 protocol, like booting and supporting Hyper-V images and therefore persistent handles. So the credit system, I've basically got a default of 40 credits, because that's fine for a loopback, but it's quite easy to configure more credits, and then it'll do the right thing with credits. In fact, Jeremy, you found I wasn't giving you a credit 1 year from as we booted. Yeah, so it's got your handiwork in this code too. I'm not sure I got a license agreement off you though, but anyway. So we have played with these other, basically the settings. We haven't got anything working, but there's enough prototype in there that you can play, which is it's a nice sandpit to play in, because it's user mode and it's on Windows. And I've also played a little bit with the network interface. So if you just grep for some of these strings, you can see what we've done. So there are some debts. In fact, there's plenty of debts. So OS X by default is configured to demand sign all the time. And whilst I've got signing working for the packets that need it, like the validate info. What's the beg your pardon? Oh, did it? Okay, so OS X may work out of the box now. Well, there's one less impediment to it working out of the box other than the rest of the code. But so single packets work, and basically it's compound. I've got a byte somewhere wrong because it says you've got to do all of the packet, including the null bit. And I'm sure I've got something. Well, anyway, I've definitely got something wrong because the computer says no still on those. So that's what I was scratching my head on this morning. And I've never touched encryption because that isn't what I'm trying to do. I'm trying to play. And encryption and playing don't feel like the same thing. The other debt then is I've done a little bit of IPC dollar, so you can connect on that, or you have to be able to do that. But I've never got as far as actually offering MSRPC protocols. And you don't need them, except that OS X gets a little bit sad if you can't enumerate your shares. So you can connect if you use the Finder, but it won't reconnect unless it can enumerate shares. So you just have to work around that. But what I've got is a cunning plan, which I'm very happy to chat about. So if we use the IDL that's in the MS PDFs, we can compile proper MSRPC on Windows, and we make a thing that offers the server service, and you can connect to it using LPC. You can connect to it using normal local name pipes. So then we take the packets off the wire that are carried on the network name pipes and put them down the LPC in the local machine, and all of that RPC parsing happens for me. So we're really close. I've nearly got this working so that I can implement all of the different RPC protocols by using the Microsoft technology. I don't touch the packets, I just pass them through and they come back again. So it turns into function calls. And then I've just got to implement. Does that make sense? I'm getting a quizzical look from Tom. Don't know.
I think he's just amused.
Oh, right.
You were talking about this small thing you were just talking about makes sense, or not the larger project?
Oh, yeah. No, not at all. Okay. So basically, using a local name pipe, we can basically use the whole MSRPC ecosystem. What was the question from?
Do I understand that right? Then, if you do it that way, all network users that are using ECRPC will actually appear as, well, your credentials when you talk to the read service. Yes.
Okay, so.
Be a little bit careful.
Yes, well, I have to be careful how I implement the server service. But then, because I can.
Run as administrator.
No. But what's interesting is if I were to domain join, or even be a PDC on a Windows server with this on the front, it isn't far away from being able to carry those packets and doing the right thing. So I'm just going to get some quizzical looks now, but I'm not advocating that. I said there's no warranties. Oh, I've got 10 minutes, and the thing after me is BS. I'm not going to overrun. Okay. Yeah, basically, we just need to get some netshare enums to get things to be nice. So there's other things we could do. I haven't used Rio yet. For people who don't know what Rio is, that's registered I/O. It's a Windows 2012 era, I believe, API that allows you to basically pre-register your memory buffers with the kernel, even in user mode, and therefore it recycles memory nicely. That is almost exactly the same model that would be required for something like SMB Direct. And what's really fun is there's a kernel mode SMB Direct. We know all about that. We've been told about Microsoft, but there's a user mode one, which is very poorly documented in MSDN. But it's got exactly the same API. It's been written for high performance computing. Oh, there's a.
The consumer side is quite well documented. The provider side is probably what you're concerned about.
Oh yes, possibly yes.
Yeah, and NDSPIv2 was released like last week. You might want to look at that.
Really? See, it's brilliant being in the room with people in the know. That's great. Thank you very much. But basically, there's some port numbers, and you could, I think, I had a little play at one of the previous Plugfests, and with this chopping off the transport TCP port 445, we can use similar calls to chop off 5445 and open that up if it's already been bound to by the proper SMB direct implementation. I'm not advocating that. Okay. And yeah, you could imagine start building the beginnings of a clustering model with this user mode. So I'm going a bit far, I admit it. Okay, legals, basically, it's an Apache 2 license. So got there. And it's live now at this URL. So please play, please make, what's it called? Fork? You'd have to fork things and then send pull requests. Except I really don't know what I'm talking about in that front, but I can code C++ and I'm sure I can merge things. So, I'm okay. Questions?
Yes. Were you familiar at all with the WinFS project at Microsoft?
Yes, I was. I was going to mention that in my slides.
About 5 years and 120 people working on it, and well, nothing shipped. But
Yes, well, I thought I might reference it, and I thought that would be rude to the audience. So yes, but I have been inspired by WinFS, because having a database in a file system is the right thing to do. Putting that in kernel mode is the wrong thing to do.
yeah, no, it's amazing that what you've done here. There's 120 people worked on it for 5 years.
Okay, well, there's 3 other devs, and we've worked about a week or 2 a year for...
So you have 600 man years of work.
They didn't have enough gin on their flights, patently. Yeah. So any questions for anyone, or comments even? But hopefully it's a little fun project, and if you want to play, then you can. That's great.
Are you going to keep coming down, or are you just done with SDC now?
No, I love coming here. It's great fun. And I want to do some of these little projects and things, but basically my day job has changed a little bit, and so I managed to persuade my new bosses to give out what we've built so far, with a view to, having a little bit of fun. As we've got to quite a jocular moment, I think it's time to declare beer o'clock. And, but thank you all for your time.